science fans, welcome back to Science Fun with Austin. Today we're going to take a look at a chemical reaction known as electrolysis. We have here an electrolyte, in this case citric acid, some ordinary tap water, 9-volt battery, and a wire. All we need to do is dissolve a little bit of our electrolyte in the water. A good mix. Alright, so we've got our electrolyte in the water, we have our battery, and we have our wire. So we stick the wire in, and you can see the one wire is coated pretty well with bubbles, and we're getting a nice stream of bubbles upward from the wire. That one's actually hooked up to the negative electrode, so the H+ ions collect on it, combine to form H2, and leak off. And an interesting fact about hydrogen is that it is flammable. You can hear the crackling of the hydrogen bubbles as they ignite. Now that we've seen electrolysis in kind of a lab setting, let's take a look at some applications for it. One thing you can try to use electrolysis for is launching a rocket. We have here an Estes hydrogen rocket set. Inside the base there you have about 6 D batteries, and in the bulb you have that same citric acid water mixture we looked at earlier. We have an igniter and then the rocket. Let's see how it works. That wasn't a terribly impressive flight, but perhaps we can do a little better. Alright, in an effort to improve performance here, we have the base, but as you can see, I've rewired this one to run off of a car booster pack. So we've got about 12 volts DC coming in from a car battery instead of a bunch of wimpy D cells. Let's see how this works. So you can see the hydrogen rocket doesn't have a recovery system on it like our conventional ones, since there's no way to initiate a secondary charge. So our recovery system is the big Nerf pad on the nose. Let's see how the more powerful version of the hydrogen rocket works. I think it works pretty well.